Welcome back to Information Systems and Cybersecurity 375. Today we're going to talk about scalable vector graphics. So there are actually two kinds of images that are commonly used on the web. The first kind of image is called a bitmap image or a raster image. Another type of image is called a vector graphics image, and that's what we're primarily going to talk about today. The difference is that a bitmap image is really just a rectangular array, usually of numbers, and each set of numbers describes the color of one pixel in the raster. And this makes a lot of sense for most computer graphics. The devices that we use to display images and even to create them, such as digital cameras and digital video, typically have sensors that are discrete and use rasters. They're raster-based. So for example, the monitor on your computer has a grid of dots, colored dots, and to display an image, your operating system or your application software will actually change the intensity of those dots using RGB codes, for example. So it makes a lot of sense if we have an image file to represent it as a raster, an array of colored dots. Bitmap images have some nice properties. For one thing, they compress nicely. The reason for that is that if I take a picture of something, or if I draw an image, typically a lot of the pixels will have the same color or similar color to the pixels nearby them. So you get these long runs of the same color or of similar colors, and compression algorithms love that. They really eat that up. Compression algorithms can compress that down into just a few bytes. They can basically say, instead of having 10 pixels and saying yellow, 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 yellow 10 times, they can say 10 yellow pixels and compress it in that manner. Unfortunately, bitmap images don't scale well. If I zoom way in on an image, the image is going to start looking grainy or blocky. And the reason for that is that I'm only storing information about each pixel. And as I zoom in, I get closer and closer to the pixel level. I begin to be able to see the individual pixels. Basically, what I have to do to zoom in is make the image bigger. And I do that by duplicating the pixels. So if I have a yellow pixel and a red pixel next to it, when I zoom in one level, I might have 2 yellow pixels next to 2 red pixels. And if I zoom in further, I'm going to get these rectangles of yellow and red, and the image is going to start to look really blocky. On the other hand, if I zoom out, I actually have to throw away information, because to zoom out, I have to make the image smaller, and that means eliminating some of the pixels that I've stored in my bitmap. So maybe I have a 10 by 10 image. To zoom out, I'm going to throw away half of them and get a 5 by 5 image. So I have to have some algorithm that decides which ones to keep and which ones to throw away. That's kind of hard. If I zoom out and then back in, I throw away all that information, and when I zoom in, it gets blocky. So this is not nice for applications where the picture needs to scale, and the web is one of those. Bitmap images are great for photographs. They're great for printers. Again, digital cameras have basically a grid of sensors, and they detect how much green light, red light, and blue light is hitting each sensor. So representing that as a number and putting it in some sort of two-dimensional table makes a lot of sense. Similarly, printers print dots of colored ink, so it makes sense to send them a bitmap image. They know exactly what color to make each dot, and they're happy. But if we want graphics that scale well, we have to use a different approach, and so we use vector graphics. Vector graphics are very different from bitmap images. Vector graphics files don't store a raster, an array of colors, blue, 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 yellow, yellow, red. No, instead, what we're going to do is store information about the geometry of the objects in the image. So we are going to store the coordinates and the width and the height of the lines and the circles and the rectangles in the image. This is great for scaling, because if I want to zoom in on something, if I want to scale it up, all I have to do is change the coordinates. I multiply them by a factor of 2 or 3, and I get new coordinates, and I can draw in the lines and the sides of the shape. I don't lose any information. If I want to zoom out and make the image smaller, I just shrink it. I divide the length or the width or the height by a constant factor, and I can zoom out. So for scalable graphics, vectors are really nice. They're also really great for drawing programs. Most drawing programs have a rectangle tool and a circle tool and a line tool, and this maps very naturally to what you can store in a vector graphics file. So this is a good match. And also, vector graphics files are pretty easy to edit or modify. Suppose I want to do some sort of animation. I have a ball, and the ball is bouncing across the screen. If I wanted to do animation with bitmap images, I'd have to draw the ball in one position, and then draw another frame where the ball is in another position, and do it again, making slight changes, drawing a whole bunch of frames, maybe a couple hundred frames. If I want to animate a vector graphics image, I just have to change the coordinates of the circle and say start here and go to here. So I can get nice animations very easily. Vector graphics are great for line art and drawing. They're not very good for photographs. Bitmaps are great for photographs, but they're not as easy to edit or animate. So there are a lot of different bitmap formats on the web. There's hundreds. Here are 4 of the most important ones. Probably the most common format on the web is a JPEG format. JPEG, JPEG, is an acronym. It stands for Joint Photographic Experts Group. They're a group of people who got together and designed this image format. Like it says, they were photographic experts. They're people who take lots of professional pictures using both film and digital cameras, and they wanted a good digital format. So the JPEG format has some advantages and some disadvantages. The main advantage of JPEG is it has really good compression. If I take a picture and I convert it to a JPEG, the file may shrink from being a couple hundred megabytes to being 2 or 3 megabytes. That's an enormous savings of disk space and also time, because the larger a file is, the longer it takes to download over the network. However, the JPEG format is lossy. It uses lossy compression. What that means is that it loses information. When I save something, when I convert it to JPEG, it actually throws away some of the information, some of the colors of the pixels. And what that means is that if you zoom way in on a JPEG image, you'll notice that it's kind of blurry. It's lost some of the color information. If you compare a JPEG with the original image, you'll notice that the colors don't quite match, because the JPEG has actually thrown away some of the color information. It's smart. It tries to throw away the least important information, little tiny details, rather than big, prominent features of the image. But you do lose information. So professional photographers, despite the fact that this was developed by the JPEG group, professional photographers prefer not to use JPEG. They will use other formats instead, like TIFF or RAW images. We're not going to talk about those. Before JPEG was popular for the web, another image format was king, and that was the graphic interchange format. The graphic interchange format, or GIF, and there is a flame war that has been ongoing for about 30 years of the proper pronunciation of this acronym, if it's GIF or GIF, but the creators of the image format pronounce it GIF, so we should too. It was created by a company called CompuServe. CompuServe was a dial-up bulletin board system. In the days before the World Wide Web was popular, before the internet was popular in the home, most users of computers would communicate by dialing into these bulletin board systems. And what that would let you do is you could dial in and leave a message, and then you'd hang up, and somebody else could dial in and read your message and reply and hang up, and you could kind of take turns communicating with each other. Some of the really sophisticated bulletin board systems had multiple telephone lines, maybe 100 lines, and so 100 people could connect at once. So if you were the 101st person, you would get a busy signal and you'd have to try again later. It was pretty slow because it was dial-up. There were lots of issues, but it's what we had. Well, CompuServe was a national bulletin board system. They had a whole bunch of servers located in several different states, and you would dial into them, and they had thousands of phone lines, so you very seldom got a busy signal. And you could communicate, and they developed this image format for sharing pictures across the bulletin board. Well, unfortunately, when CompuServe designed the GIF format, they used a compression algorithm called Lempel-Ziv, and the Lempel-Ziv format actually has been patented. It had been patented by a company named Unisys. They make cash registers and other kinds of machines, adding machines and things. And Unisys threatened, after GIF had become the most popular image format, they decided they were going to pursue their intellectual property, and they announced that they were going to start suing people who used it without paying them royalties. This immediately caused all sorts of consternation on the web. People were scared, oh no, my website's going to get sued, and so they stopped using GIF, even though Unisys had promised only to go after large corporations and not everyday users. GIF is still around. It's most commonly used for animation. There's a really easy way to generate an animated GIF format. Again, you have to generate each frame, but you can specify the delay between each frame, and the animated GIF will play it back for you. But otherwise, it's not as common as it used to be. JPEG has really taken over on the web. About the time that this controversy about GIF started with the patent, a group of people got together to find an alternative graphics format, and they called it PNG, PNG, or Portable Network Graphic. So the Portable Network Graphic image is an alternative to GIF. It's a lot like GIF. It has some nicer features. For one thing, it supports alpha blending, which the original GIF format didn't. Extensions to it have added that feature in GIF. But it's open source, it's free, anybody can use Ping and not have to worry about patents or copyrights or any other kind of encumbrance. So Ping has become popular, and it's increased in popularity. It's still behind JPEG in terms of usage, but only by a little bit. Finally, another important format is called NetPBM format. You've probably heard of GIF, JPEG, and Ping, but you probably haven't heard of NetPBM. NetPBM was created by a teacher specifically for academic use. And the idea is to have an easily editable image format that makes it easy to teach bitmap images. And it turns out that it's very successful. It's very easy to parse because basically we're going to store each pixel as a set of 3 numbers in text, so you can edit it in Vim or Notepad. And because it's so easy to use, a lot of software supports the PNM format. So it's become pretty common for that reason. So here's an example of a bitmap file, and this is in PNM format because, again, it's the easiest one to share and explain. So this is only 4 lines. This is the entire image. The first line says P3, and that's called a magic number or an image identification code. Basically what it does is it identifies what kind of image file this is. The P tells us it's a PNM file, and the 3 says that it's version 3. Now format 3, or version 3 of PNM, is the full color ASCII text format. P1 files use black and white. P2 provide grayscale images. If you want full color, you use P3. P4, P5, and P6 are similar to P1, P2, and P3, except instead of storing the pixels as text characters, they actually use binary, which compresses the image a little bit and makes it more suitable for copying over the network. It's pretty easy to convert between the formats, but we're going to use the P3 ASCII format. The second line of the file says 4 to 255. The 4 and the 2 are the width and the height, and the 255 is the maximum color value. So we're going to have red, green, blue values, RGB values, and the amount of red, the amount of green, and the amount of blue will be expressed as a number between 0 and 255 inclusive. So then the next 2 lines of the file are the 2 rows of the image. In each row we have 12 numbers. Each triple of numbers, each set of 3 numbers represents 1 colored pixel on the screen. The first number is the amount of red, then the amount of green, then the amount of blue. And we have 4 of them because we have 4 columns. So there's 4 triples, 4 ordered triples. Red, green, blue, red, green, blue, red, green, blue, red, green, blue. So if you look at the first row, all 4 of the pixels have the pattern 255, 2550. That means we have the maximum amount of red, the maximum amount of green, and we have no blue. So if I mix red with green on the computer, I get yellow. So I've got 4 yellow pixels in the top row. In the bottom row, I have 00255, 00255. 00255 means no red, no green, and maximum blue. So this is going to be a blue pixel. We have 4 blue pixels. So the top row is going to be 4 yellow pixels. The bottom row is going to be 4 blue pixels. So I'm going to have a yellow line and a blue line immediately underneath it. And if I pull it up in an image editor, it looks something like this. Now I've zoomed way in on this. Remember, each of those sets of numbers is one little tiny dot on your screen by default. So I've zoomed in 32 times. I've zoomed in a factor of 32, and so you can actually see what this looks like. And you'll notice on the top we have 4 yellow pixels. You can't see where one pixel starts, the other stops, because they're right next to each other. And beneath that I have 4 blue pixels. Now notice that this is kind of blocky looking because I've zoomed way in, and each pixel is a little tiny rectangle or a little tiny square. So it looks like a yellow rectangle over a blue rectangle. If I were to zoom way out, you could barely see it, but it would look more like 2 little lines. So I mentioned before that bitmap graphics don't scale well. If I shrink them, I lose information. If I expand them, it looks blocky. If I want to have something that works well on the web, I need a vector graphics format so that I can scale my image nicely on browsers with different size screens. So the solution to this is to use a file format called SVG, which stands for Scalable Vector Graphics. Again, because it's a vector graphics format, I'm going to store shapes instead of pixels. I'm going to store the geometry of the shapes. So I'm going to say draw a circle here and make it this big. Draw a rectangle here and put it here and make it this wide and this tall. SVG is kind of a neat format because, like HTML, it uses markup. It uses tags. So we're going to have elements and entities and attributes just like we do in HTML. In fact, both HTML5 and SVG are loosely based on XML, which was a very popular markup language format that was used as sort of a template for many languages when the web was really new and exciting. Kind of in its adolescence, actually. Not brand new, but developing. So here's an example of an SVG file. Notice I have an SVG tag and a /SVG tag at the bottom. The SVG tag at the top is sort of like the HTML tag we put at the top of a web page. And the /SVG tag is sort of like the closing tag, the /HTML tag we put at the bottom of a web page. So this says the image starts here and it ends here. The difference is that with a web page, I can only have one HTML and one /HTML page. But with scalable vector graphics, I can actually have multiple images on the same page. So I can have an SVG tag and some shapes and then a /SVG tag. And I can have another SVG tag and some shapes and another /SVG. And that would put two images into my web page. Also, as we'll see later, I can actually embed one image inside another. So for example, if I drew an SVG image of a horse, I could take that image and I could use it inside another image. Maybe I have an image of a barn and I want to have horses in my barn. I could pull in the horse image and use it multiple times inside my barn. So I can have nested SVG tags. That is, I can have an SVG image inside another SVG image. So here in my example, I have my SVG tag and my /SVG tag, and in between I have two circles. The first circle is going to be centered at 2020 with a radius 10, and it's going to be filled with black paint. The next circle is going to be centered at 1010, so a little further up and to the left. It's going to also have radius 10, but it's going to be filled with red paint. So if I pull this file up in an image editor, it looks like this. I want you to notice that order matters. So because I drew the black circle first, it shows up behind the red circle. So the order of your tags matters in SVG. In this case, the black circle was drawn first because it was the first tag, the one at the top of the file, and the red tag came second, and so it's drawn on top. So a little bit about this. First of all, every image begins with SVG and ends with /SVG. There's a couple different ways we can load them into a web page. One way to do that is to load it with the IMG tag, just like we do with raster images, with bitmap images. If I load a JPEG or a PNG, I can use an IMG tag with an alt attribute and a source attribute and load the image into the page that way. However, in HTML5, I have a new option. In HTML5, SVG tags are also legal HTML tags. So I can embed my SVG graphic directly into the code for my web page, and it'll render and draw. That's pretty cool. Another way that I can do this is if I already have an SVG image, I can pull in another SVG image as part of it. We already talked about that. If I have a barn image, it can use a horse image inside. It'll treat the horse like a shape, just like a rectangle or a circle, and I can position the horse where I want it. So the SVG tag itself can take some attributes. First of all, it can take an X and a Y coordinate. Those are only used if it's a nested SVG element. That is, if it's an image I'm pulling into another image. So for example, if I have my barn and I want to put the horse here, I could give it an X and Y coordinate to put that horse SVG. And then if I have maybe 2 or 3 horses, I could specify different X and Y coordinates for each one, and it would draw them in the appropriate place within my image. The other attributes that I can give the SVG tag are a width and a height. Now, the web browser may scale the image. If I'm on a big screen, it may expand it. If I'm on a little tiny screen, it may shrink it. So the width and the height that you give the SVG tag are really the default size of the element. Typically, the idea is to give some sort of standard so that when I specify like a width or a height for one of the shapes, it knows what it's comparing it to. It knows, it can relate that width to the width of the entire image and say, okay, I know that this is 10 pixels compared to 50. If I scale this thing up so that it's a 100 by 100 image, I'm going to double the 10 too and make it a 20 by 20 rectangle. So there are many different kinds of elements that are available in SVG, but the 4 most important are basic shapes, paths, text elements, and images. You can actually pull raster images into an SVG image as a shape. We're only going to talk today about the basic shapes. In the next lecture, we're going to talk about paths and text, as well as some advanced features of SVG, like the ability to group things and pull in raster images. So the basic shapes are lines, rectangles, circles, ellipses, and then there are two kind of special shapes, what we call open shapes and closed shapes, or polylines and polygons. We'll talk more about those in a minute. Almost every SVG element, any basic shape, will take these four attributes. It can take a fill color. Actually, it can be a fill color, or it can be a pattern or a gradient that we fill with. We'll talk more about paint in the next lecture. It can take a stroke color. That's a color for the border around the outside of the element. It can take a stroke width, which is the thickness of that border. And finally, it can also take a style attribute, which gives us even more flexible styling of the element. So the style attribute is a little bit like a CSS rule. It allows us to apply CSS-like rules to our SVG elements. Actually, if we're embedding an SVG element into an HTML5 page, we can use actual CSS to style it as well. And CSS3 has special selectors and rules for dealing with SVG elements. So if you want to draw a line, we do it with a line tag. And the line tag takes four attributes. It takes an x and a y coordinate for the starting point, and an x and y coordinate for the ending point. So x1 and y1 specify the starting point, x2 and y2 specify the ending point. And of course, I can also use the other attributes I mentioned, the fill color, the stroke width, and the style. So here's an example of an SVG image. I'm going to set the width and the height to 50, so it's a 50 by 50 image. And I'm going to draw two lines. The first line is going to go from the coordinates 10, 10 to 30, 40, and it's going to be stroked with black ink. So this is a black line. The second line is going to start at 30, 10 and go down left to 20, 40, and it's going to be stroked with blue ink. So if I were to type this into Notepad or to Vim just like it is, and pull it up in a web browser or in an image viewer, this is what I would see. Something like this. My black line starts at the top left and goes to the bottom right. Blue line starts at the top right and goes down to the bottom left. Again, notice the order matters. The blue line is on top of the black line because I drew the black line first and then drew the blue line over the top of it, right? On top of it. I can draw rectangles in SVG. Rectangles take actually 6 attributes. 2 of them are optional. The 4 required attributes are an x and y coordinate. That's the coordinate of the top, those are the coordinates of the top left corner of the rectangle. I also give it a width and a height. Optionally, I can provide rounded corners for my rectangle. I can have a rounded rectangle. And if I want that, I specify Rx and Ry, which are the radius of the corners, the rounding. So Rx gives you the x-axis, or the x radius, and Ry gives you the axis in the vertical dimension. So here's an example of drawing rectangles. Again, I'm going to have a 50 by 50 SVG image. The first rectangle will go from 10, 10, and it'll be 20 pixels wide, 15 pixels tall. I'm going to fill it with red paint and stroke a black border around it. The second rectangle is going to start at 25, 25, so it's actually going to be in the middle of the red rectangle. The top left corner will be right in the middle of the red rectangle. And it's going to be a 10 by 25 rectangle, which I'm going to fill with blue paint and put a white border around. So that looks like this. Notice, again, the red rectangle is behind because I drew it first. The blue rectangle was drawn last, so it's above the red rectangle. You can kind of see the white border on one corner of the blue rectangle. On the other side, you can't really see it because I've got this on a white slide, and so the border kind of blends in with the background of the slide. I can draw circles. The circle element takes 3 attributes. Cx and Cy are the coordinates of the center of the circle, and R is the radius. So for example, I can draw a circle centered at 25, 15 with a radius of 10 pixels, and I can fill it with green paint. And that looks like this. You'll notice that because I drew it at x coordinate 25, that it's centered from left to right. But vertically, it's a little off-center because instead of putting it at 25, I put it at 15, so it's shifted up a little bit. In computer science, we draw things in the fourth quadrant, which means that y coordinates increase going down. X coordinates increase from left to right. Y coordinates increase from top to bottom. So the top left corner of the screen is 0, 0, the origin. And as I add to my Y coordinate, I go down the screen. So in this case, 15 is above 25. I can draw circles. I can also draw ovals or ellipses. The ellipse element takes 4 attributes. It's a lot like the circle. I specify the center coordinates. I also give it 2 radii. I give it an x radius and a y radius, and these are the lengths of the x and y axes of the ellipse. So here's an ellipse centered at 25, 25, right in the middle of the image. I'm going to give it an x width of 10 and a y axis of 15 pixels, so it's going to be taller than it is wide. And I'm going to make this one purple. So it looks like that. So the polyline and polygon elements are more complicated. If I want to draw just a rectangle or a circle or an ellipse, that's pretty easy to do. But if I want to make a more complex shape, I need to specify several different corners. And so polyline and polygon both have one attribute, one required attribute, and that's a list of points. And it's just named points. And it's a space-separated list of pairs. So we'll see what that looks like in just a second. The difference between polyline and polygon is that polyline makes an open shape. That means that the starting point and the end point aren't necessarily the same. Polygon makes a closed shape. That means that my starting point and my ending point are the same. I draw sides on the object, little line segments, and I come back to where I start. So polyline you can think of as a bunch of connected line segments that may or may not connect back to the beginning. But polygon is a closed shape. It always ends where it starts. I can fill a polygon. I can fill a polyline. It looks kind of weird if I fill a polyline. Because it's open, it'll fill, it'll sort of add a side almost with fill, but it won't put a border around it. It looks really weird. So here's an example of a polygon and a polyline. Again, I'm using my 50 by 50 SVG image. The polygon is going to be yellow, and I've given it a list of points. So the first point is at 25, 25, the center of my image. And then it goes to 20, 30. So it's going to go down to the left slightly. And then over to 10, 30. Then to 17, 35. 1545, and it's just going to keep going to all these points that I've listed. Notice that it comes back to 25, 25 at the end. I think I actually could have omitted that. I think it would automatically come back to the start, but I didn't test that. The polyline has no fill, but it has a stroke width of 1, and I'm going to stroke it black. And I've given it a set of points. The first x coordinate is 10, and it's at a y coordinate 49, so it's going to be at the bottom left. Then I'm going to go right 5 pixels and up 3. So it's going to go up and to the right. Then 2049 is down and to the right. Then up and to the right. Then down and to the right. So I'm going to get kind of a wavy line. And it will be black because I'm stroking it with black ink. So here's my image. Notice my yellow polygon forms kind of a star. I notice now that that's really hard to see on a white background. I'm sorry about that. But yes, it makes a little star. And you can see that it starts and ends at the top corner. The top corner is at 25, 25, and it goes from there. My polyline, my little wavy line, is at the bottom in black. If I were to fill this, it would actually fill and look sort of like mountains. So it would, maybe I filled it green, right? It would look like 3 little triangles, boom, 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 all filled with green, but it wouldn't flood the document or anything like that. So in summary, scalable vector graphics are very useful. They can be smoothly resized. They store data using a collection of shapes rather than a raster of pixels. Using SVG, you can draw lots of different shapes, but among them are rectangles, circles, lines, text, paths, and we're going to talk about several other things that you can do in the next lecture. You can set a stroke and a fill and a stroke width, or even a style on all of these elements. And it's really important to remember that the first element you draw will appear behind the other elements, so the order matters in the SVG document. I've enjoyed being with you. This has been a great class so far. Please keep working on your projects, and feel free to contact me if you have any questions. I'm enjoying this class, and I hope you are too.